So in order to write Csound code, you have to understand the Csound syntax, and there's no shortcuts here. So I'm going to just give a brief overview of Csound variables, which are very important building blocks for your instrument. So I'm going to create a new instrument, test, save, replace. And I'm just going to take this out of here. Okay, so we saw previously that the CS instruments section is the brains of the operation in terms of how you're going to build your instruments, where you're going to find your algorithms, how you're going to do your processing, etc., etc. So we need to look at variables. Variables in Csound are really easy to identify. They're going to begin with an I, for example, IAMP. Let's say IAMP is equal to 10. They can begin with a K. KAMP is equal to 10. Yeah, I shouldn't say KAMP is equal to 10. I should say KAMP is going to be assigned the value of 10 because this is an assignment operator. Rory. So KAMP, IAMP, and then we've got AAMP. So we could do assign the value of 10. We've got SAMP with a capital S, and that's a string. So I'm a string. And then we finally got G variables, which are global variables. So to turn any one of these into a global variable, we just put a G at the start. Okay. So why all the different types of variables in Csound? Well, we'll start with the first one, IAMP. IAMP is known as initialization variable or init variable. It takes one value when the instrument is instantiated, and it keeps that value for the duration of the instrument. For example, I'm going to take P4 from here. So this little bit of code up here tells Csound to pass the MIDI key to P4, right? So that's this 4 here is related to this 4 here. Okay. I say okay a lot, get used to that. So now, actually I should be using P5 for the amp because it's actually coming from here. So I can print IAMP, I can save this, and every time I push a button here, we get an amplitude value down here. Okay. So there, if we play the note at the top, it's very quiet, and if we play the note at the bottom, it gets louder. Okay, so it's getting close to 1. So if I play right at the very end, we're getting very close to 1. Okay, so initialization variables or init variables can change during the performance of a note. So IAMP, for as long as the note is held, is going to remain the value of P5. If we could do a KAMP, I'm going to use a very simple opcode called line. So what line does is it draws a line between the start point and an end point in this length of time. So in 100 seconds it's going to output values between 0 moving upwards to 1000. So now I can use print k, which is going to print a value at a time determined by us, which is, in this case, I'm going to say every second, and then I can pass a value like km to it. So now when I press the button, and when I press this button, or press any button on this keyboard, this instrument over here is going to start. And basically this instrument is going to keep playing through in a loop, in a loop, in a loop, essentially for 44,100 times a second, or whatever sample rate has been determined as. So press this, and now we can have a primitive counter moving upwards all the time. So we can see there the K-rate variables can update during the performance of a note. Now if I was to cast this as an I-rate variable and I press the button, we would see that the value stays the same. So just these values here are the actual time that's passed, and these values here are the values that have been, these values here relate to what this value here is. Okay, so K-rate variables can be updated over time. Now how quickly they update is determined by the KSMPS value. Okay, KSMPS in this case is set to 64, which means that every 64 audio samples, a K-rate variable is updated. So the audio samples are updated 44,100 times a second. We can change this A-amp to line 0100 dash. That will work when we press a note, no problem. The thing is, we can't print directly A-rate variables to the console down here because it's way too many happening every second, or too many updates. So there's 44,100 possible values for A-amp every second. So we just cause the machine to blow up. So the thing about audio rate variables is, if we can do some kind of simple diagram here. So if you like, this is every audio rate update. So there's going to be 44,100 of these happening every second. The difference between audio rate updating and K rate is something along these lines. So you might have a K rate variable might update there, maybe it updates again here, updates again here, updates again over here someplace, and then over here. But we can see clearly that it's not updating as fast as our A-rate variables. So the reason why there's different speeds of variables is basically to do with performance, instrument performance. You don't need to be updating every variable 44,100 times a second. In doing so, you might end up slowing down the process, which can cause audio dropouts, and that's the last thing you want. It's the audio dropout. Oh, terrible, because then you'll have a kind of sound. That's not what you want at all. So that's about as quick an introduction as you're going to get on Csound variables.